People ask me all the time, as a theoretical physicist, when the universe will reveal its next stunning secret. My answer is simple. That moment is unfolding right now. A visitor from the cold, empty reaches between the stars, cataloged as 3I Atlas, is cutting through our neighborhood at astonishing speed. We first noticed it in July as a faint glimmer, barely distinguishable from the background stars. Today, what our telescopes show is something very different. We are watching physics happen in real time, plasma dancing with radiation, dust and gas reacting to a blistering solar environment, and humanity's observational network being tested like never before. Right now, 3I Atlas sits at less than 2 astronomical units from the Sun and is hurtling along at roughly 60 kilometers per second, still accelerating. When it makes its closest approach, perihelion, between October 29th and 31st, speed should climb to near 68 kilometers per second. Picture that. An interstellar object, born around another star, now plunging into the furnace that surrounds our Sun. The next several days are critical. On October 3rd, 3I Atlas skimmed past Mars, coming within roughly a quarter of the Earth-Sun distance from the planet. That alignment is a gift. While Earth-based telescopes struggle with solar glare, the suite of orbiters around Mars enjoys a clear, powerful vantage point. Mars Express and the ExoMars Trace Gas Orbiter stand ready in Europe's corner. In orbit for the United States, the Mars Reconnaissance Orbiter, with its high-resolution cameras, and MAVEN monitoring the atmosphere, are well-placed too. And if mission teams can reorient their sensors quickly, other assets orbiting Mars may contribute corroborating images and spectra. Parallel observation like this is how we separate speculation from discovery. So what are the instruments actually seeing? Start with brightness. 3I Atlas has surged toward about magnitude 12, too faint for the naked eye, but readily visible in modest backyard telescopes. More strikingly, its brightening departed from our models in early mid-September, at roughly the 2 astronomical unit mark. It's glowing far more intensely than our calculations expected. Some of that disagreement can come from measurement differences, telescope size, exposure stacking, processing choices. But then came a compelling piece of evidence from Perseverance on Mars. On October 2nd, during stacked nighttime exposures, Perseverance recorded a narrow diagonal streak crossing the star trails. The streak appears across multiple consecutive frames and shows elongation consistent with a very fast object moving through the field during each exposure. This is not the signature of a random cosmic ray or an ordinary Martian satellite. The timing, direction, and kinematics line up precisely with what we'd predict for a high-speed interplanetary visitor. Could that streak be 3I Atlas? The resolution is modest, but the implications are electrifying. This is how genuine discovery accumulates, piece by piece, each observation demanding independent confirmation. Now imagine the geometry. On October 21st, superior conjunction places the Sun almost exactly between Earth and 3I Atlas. From our ground-based perspective, we enter a blind period. Solar glare overwhelms telescopes. It is a beautiful irony of modern astronomy. We can image the shadow of a black hole millions of light years away, yet a small rocky traveler near Mars can disappear when it tucks too close to the Sun's apparent position. That is why the Martian observation window matters so much. After conjunction comes perihelion, that decisive passage between October 29th and 31st, around 0.36 AU from solar center. If 3I Atlas is going to flare, fragment, or otherwise change its appearance, the physics nearly forces those events to happen then. Jets, sudden brightening, structural breakup. These behaviors will almost certainly reveal themselves during that passage. After perihelion, longer-term programs will kick in. Spacecraft deeper in the inner system will begin extended baseline monitoring. Some data, because of geometry and operations, may not appear in public archives until months later. Scientific work often looks like a relay. One instrument hands off to the next and the full picture slowly comes together. Step back for a moment. In under a decade, humanity has encountered 3 confirmed interstellar visitors. Each one has challenged our expectations. Right now, 3I Atlas is acting like a natural laboratory. It shows how frozen interstellar material can wake up under intense solar radiation, how dust and ionized gas organize into sunward structures, and how chemistry in the coma can ignite almost instantaneously, as if flipping a switch. Spectroscopy will be decisive. Will we see classic swan band emissions from diatomic carbon? Or will the colors stem from plasma interactions and photochemical breakdown? The green glow some observers report could tell us whether we re-seeing familiar cometary chemistry or something more exotic. The brightness curve, whether a brief spike or a sustained climb, will help determine whether this is a single outburst or an ongoing process. Beneath the technical details is a quietly profound truth. We tiny inhabitants of a fragile blue sphere have built a surveillance network around another world so that for a few valuable days, we can watch an interstellar traveler thunder past our cosmic doorstep. Where ancient cultures saw omens and portents, we now see moving experiments, natural testbeds revealing physical laws in extreme conditions. 3i Atlas might never blaze across our skies and dominate the twilight. It may not become the kind of spectacle people remember for generations. But in the data it leaves, the spectra, the stacked images, the plume geometry, the perihelion behavior, there is something far more permanent than spectacle: knowledge. If you want to understand how science actually advances, watch this one closely. Progress rarely arrives as an emphatic proclamation. It arrives as careful measurements, uncertainty bars, independent confirmations, and the intellectual courage to follow where the evidence leads. In a few weeks, from Earth's perspective, 3i Atlas will slip behind the sun and disappear. In December, it will re-emerge, transformed, or perhaps eerily familiar. Then we will measure it again. We will compare before and after. And someday soon, perhaps in a graduate student's thesis, a paper will begin. We report observations of 3i Atlas during its perihelion passage, including, and it will list the Martian campaign, the ground-based stacks, the perseverance streak, the brightness anomaly near 2AU, the green envelope, and the anti-tail structure. That paper will be another page in our cosmic encyclopedia. Until then, keep your skepticism healthy, your curiosity boundless, and your attention trained on the instruments. The universe owes us no simplicity, but it does obey consistent physical laws, and those laws are listening, and so are we.